Okay, good morning class. So today we're looking at trigonometry. So at this point we have concluded exercise 2 and exercise 1 as well. So now we're going to look at the examples for exercise 3, which is dealing with the double angles. Okay, so we've done the compound angles, now we're looking at the double angles. Okay, so something to note at this point. Okay, this is examples for exercise 3, which is on page 98. Okay. Now reading from page 96. Okay. So here we are told that the double angle identity, which is sine 2 theta is equal to sine 2 sine theta cos theta, and cos 2 theta is equal to cos square theta minus sine square theta, or 1 minus sine square 1 minus 2 sine square theta, or 2 cos square theta minus 1. These identities derived from the compound angles identity by letting 2 theta equals theta plus theta, or 2x is equal to x plus x. Okay, so this basically comes from your previous exercise. Okay, this is from exercise 2, number 5.4. Okay, so how do you actually derive this? I know you guys haven't done your homework for the even numbers list today, so I'll show you basically how we derive this formula. So we're going to look at the derivation. How do we actually derive the sine 2x formula? Okay, so the hint was given, and I know you guys haven't done it, so I'm going to take my time out to quickly do this here. We know that sine 2x, okay, sine 2x, this can be written as a compound angle, or as two angles being added. This can be written as sine x plus x. What's x plus x? 2x. If this was sine 2 theta, then it could be written as sine theta plus theta. If this was sine 14m, then this can be written as sine 7m plus 7m. You guys understand? So, as long as it's a double angle, it can be written as the halves of that being the sum of taken in that case. Okay, you all agree with that? Now, if you see your sine alpha plus beta, what is the sine expansion on this compound angle? Sine alpha cos beta plus cos alpha sine beta. Let's say, hang on, what if I put an x there and an x here? Then what is it going to read now? Sine x cos x cos x sine x. Not so. So if I write that down there, it's going to become sine alpha cos beta plus sine beta cos alpha. You all agree with that? Or cos x sine x. No, this I always mix it around. Sorry about that, it was confusing you. Okay. But what do we notice now? Like this, which now can be written as 2 sine x cos x. And there is the first of the compound double angles produced. So put that in the box. The first of the compound double angles. Okay. So sine x is equal to 2 sine x cos x. Okay. Alright, let's look at the next one. The derivation of cos 2x equals cos squared x minus sine squared x. Okay. So let's go with cos x, cos 2x. We see cos 2x can be written as what? Huh? Cos x plus x. I'm going to have to prove that, no? So cos x plus x. So you say, okay. Now what can be done? You can of course use the cos expansion. Not so. So, remind us, what is the cos expansion for cos alpha plus beta? Cos alpha, cos beta, minus sin alpha, sin beta. Not so. But what will happen if I change this to x and an x? This will be cos x minus sin x, sin x. So that is going to be cos x times cos x minus sin x times sin x. But what is cos x times cos x? Cos squared x. What's sin x times sin x? Sin squared x. So there is your second idea. Okay? Sin squared, no? Don't need to be confused. So cos 2x can be written as cos squared x minus sin squared x. But what is this cos squared x? What is cos squared x also equal to? 1 minus sin squared. Where am I getting that from? Yes, we'll start. The fact that cos squared x plus sin squared x is equal to 1. So of course cos squared x is equal to 1 minus sin squared x. So hang on. Sin squared x is also equal to 1 minus. So let's change 1 and see what happens. Let's change cos x, cos squared x. Okay, so what do we get? Cos 2x is also equal to 1 minus sin squared x minus sin squared x. But what do we see now? Like terms again. So it's 1 minus 2 sin squared x. So, but that's now another formula. That's formula number 3. That cos 2x is equal to 1 minus 2 sin squared x. You say, okay, let's see what happens if we change the sin squared x. And what would sin squared x be written as? So cos 2x is equal to 1 minus, in brackets, 1 minus, no, sorry, my mistake. I'm going with this formula. So cos 2x is equal to cos squared x, yes, minus, in brackets, 1 minus cos squared x. What do we do now? Multiply, get rid of the brackets. So it's cos squared x minus 1 plus cos squared x, which is 2 cos squared x minus 1. And this is cos 2x. There's another formula. Okay. So what do you notice about cos? How many formulas do we have? 3. Whereas for sine we have 1. Right, you guys understand? See any confusion? Right, let's go to the next page. Okay, that one we just derived. Now we're going to look at the examples, and the examples on page 96. Right. This is still for exercise 3 on page 98. Alright. So here we say write sine 10a in terms of the ratio of angles of 5a. Just to refresh our memory, what formula did we just prove now? We derived formulas for cos 2 alpha, which can be written as 2 cos squared alpha minus 1. Also, cos squared alpha minus sine squared alpha. And 1 minus 2 sine squared alpha. Then we have sine 2 alpha can be written as 2 sine alpha cos alpha. Okay. So the question says write sine of A in terms of the ratios with angles of 5A. So sine A can be written then as what? Sine 10A can be written as what? Sine 2 times 5A. Not so. Why did I write it like this? So that it can be in this format here. Can you see that, people? So what is my alpha angle here now? What's my alpha angle now? 5A. So if you go here, sine 2 alpha is going to be 2 sine alpha cos alpha. So sine 2 into 5A can be written as 2 sine 5A cos 5A. You guys understand? Fairly simple, huh? Sorry about this. Okay. Any confusion at this point? No. Right, let's carry on with our lives. Example 2. Look at lower down. And make provision for the other derivations. We are just reminded of the double angles we have just derived. People, the question says write cos of 8a in terms of sine 4a. So where do we start? We say cos of 2 times 4a. Now for the cos, these are how many for cos? 3. So if it was cos squared 8 sine squared 8, then I would have written, what's your alpha angle now? 4a. Then I would have written cos squared 4a minus sine squared 4a. If it asked me for cos, then what would I have written? 2 cos squared 4a minus 1. But what did they ask us? Sine. So I'm going to write it as 1 minus 2 sine squared 4. Do you guys understand? Is there any confusion? No? It's too easy to be confused about, no? Yes. Right, let's look at the next one. The geometry, this trigonometry is almost becoming your favorite after geometry. No? People, evaluate also mean determine or calculate or simplify whatever. Cos squared 15 minus sine squared 15. People, where did we see that before? The cos double angle, not so. So what's my alpha angle now? 15. So in other words, it's cos squared alpha minus sine squared alpha. You see it's the same. So you could be written like it. So what is cos squared alpha minus sine squared alpha? Sorry? Cos 2 alpha. Have you heard somebody say 1, 1? Okay, is cos squared alpha minus sin squared alpha 1? No, it has to be plus. Cos squared alpha plus sin squared alpha is 1. Cos squared 15 plus sin squared 15 is 1. Cos squared 15 minus sin squared 15 is not 1. Okay? We know that cos squared alpha minus sin squared alpha is cos 2 alpha. And what's my alpha angle here? 15. So in other words, it's going to be cos 2 times 15. What's 2 times 15? 30. Right, you guys are showing some promise there. Now you guys know what 2 times 15 is. And what is cos of 30? Special angle. Remember, for the special triangle, I always encourage you to draw the following. There's going to be 30, 1, 2, root 3. Remember, what does cos stand for? Jason of hypotenuse. There's going to be root 3 over 2. Root 3 over 2. Okay? Any confusion, people? No? You're asking, where's the exciting sums? The ones that must make you think. It's coming. Right, here the equation number 4. To write 2 cos squared a over 2 minus 1 in terms of cos a. So where did you see? So what I do, I say, okay, instead of seeing that funny angle there, I replace that in my mind with an alpha. No? So in other words, what I should be seeing is 2 cos squared alpha minus 1. But where did I see that 2 cos squared alpha minus 1? Fine. 2 cos squared alpha minus 1 is also equal to cos 2 alpha. So here we have 2 cos squared. What's your alpha angle now? A over 2. So I replace that with a over 2, the. So this will become cos 2 multiplied by a over 2. You guys understand? 2 multiplied by. So there we write. That will be cos 2 alpha. And what's my alpha angle? A over 2. So what happens? What is 2 multiplied by half a? A. So that's gone. The answer is cos of it, which is what they do. Okay? Any confusion there? No, let's carry on. Now in number 5 you are told, find cos of 2a if sine of a is equal to negative 12 over 13 and a is greater than 0 but less than 90, which 270, which means to say what does that mean to say? This tells me that sine is negative. Of course, we're going to draw a diagram, not so. Sine is negative. So, we ask ourselves, okay, where's sine negative? Where's sine negative? 3. Then we are told it's greater than 0 but less than 270. So it's quadrant 1, 2, and 3. So which quadrant are we going to draw in? 3. Okay. So let's draw 3. What does sine stand for? Opposite of hypotenuse. That's my reference angle. Opposite is 12, hypotenuse is 30. This is on the positive or negative part of your y-axis? Negative. Hence that negative there. Remember, this length will never be negative. Hypotenuse is never negative. So how do I get the adjacent? Pythagoras. The 13 squared minus, in brackets, negative 12 squared will give you 25. The root of that's going to give you 5. But you say, hang on. This is on the negative part of your x-axis. So it will be negative 5. Now I can conquer the world in trig. Why? Because I got 3 sides in a right angle triangle. Okay. So what did they ask us? They asked us in terms of cos of 2a. So cos of 2a can be written as what? Which one am I going to use? You want to use the first one, okay? So it's going to be 2 cos squared a minus 1. So it's 2 into, what does cos stand for? Adjacent of hypotenuse. It's negative 5 over 13 squared minus 1. So you put that in the calculator, 2 into negative 5 over 13 squared. Minus 1. Gives you negative 119 over 169. But Ms. Haas says she's a sine kind of girl. No? So rather want to use sine. Let's see what answer she would have gotten. What answer do you think she's going to get? Same. Why? Because the identities are equal to the same, which is cos 12. So it's going to be 1 minus 2 into, what does sine stand for? Opposite over hypotenuse. So it's negative 12 over 13 squared. Let's see. How far we? So it's 1 minus 2 into negative 2 over 13 squared. Hang on. Same. So while we're at it, let's test the third one. Just for fun, eh? Let's see, you don't do all 3 people. I'm sure you do one of the 3. Okay. Well, don't say there's too many options, so I'm going to leave it blank. No? You can do any of it, okay? So you're going to be cos 2a. It's going to be cos squared a minus sine squared. So cos is adjacent of hypotenuse is negative 5 over 13 squared minus negative 12 over 13 squared. Here we have in brackets negative 5 over 13 squared. Minus open brackets. What do you notice? Same answer of negative 199, negative 119 over 160. People, you guys understand? Easy, no? Okay, don't hear that yes too loud. Number 6, if sine of 40, if sine of 40 is equal to 1 over 8, determine cos of 80 and cos of sine of 280 in terms of 8. So what do we have to do here? Construct a triangle, yes. So what does sine stand for? Opposite over hypotenuse. Which quadrant will this be? First. Do I have to draw this in the first quadrant? I could have drawn it without the cos diagram, without the Cartesian plane, because that's an acute angle. Okay? I could have just drawn it as a triangle with a 40 degrees there. Then what will the size of this angle be? This is 40, 90, 50. Not all everybody at once. No? The weekends are good for you. But what does sine stand for? Opposite which is 1. Hypotenuse is 8. How do you calculate the adjacent side? Pythagoras. So hypotenuse squared, so your adjacent side squared is equal to hypotenuse squared minus your other side squared. Okay? Now do you get the adjacent side on your own? I take the square root. So the adjacent is equal to the square root of a squared minus 1. Or can I write it as a minus 1? No. Why? You guys should have known I was going to ask you why. Because of the negative sign between it. Okay? Have you answered the question? No. Let's answer the question. You will say cos of 80. So what I need to do is I need to link this 50 or this 42. You see that? 50 and 40. So cos of 80, how are you going to link 50 or 40? 2 multiplied by? Huh? 2 multiplied by 40. Nice. So it's cos 2 times 40. So what does this remind us of? The cos double angle. Which one do I use? I can use any one. Why can I use any one? Because it wasn't specified which one I must use. If it's not specified, I can use any one. Okay? So cos of 40. 2 into 40. So what's my alpha angle? 40. Right? So I'm going to go with the first one. There's going to be 2 cos squared 40 minus 1. So what is cos of 40? What is cos of 40? What does cos stand for? Adjacent over hypotenuse. So it's going to be the square root of a squared minus 1 over a squared minus 1. Okay. So this will be 2 into. The square root and the square will cancel in the numerator. So it's going to be a squared minus 1 over a squared minus 1. Okay? And from these it's a matter of simplifying. So my LCM of course here is a squared. So that will be 2. I'll multiply the 2 into a squared minus 2 minus 1. A squared. Which gives me a squared minus 2 over a squared. Some algebra coming into play. Okay. If I had gone with the sign, I would have gotten the same. The one dealing with sign, I think it would have been much shorter. That's the thing when you're choosing. Okay? If you choose anyone, 2 of it will take you an extra step to get back to where you need it to be. You guys understand? Because it's based on your squared identity. Okay. If I go with the one dealing with sine, it would have been 1 minus 2 sine squared 40. Now sine we know was 1 over a squared, which is 1 minus 2 over a squared, which is exactly that here. But you guys will say, okay, but I don't see it. Your LCM of course is a squared, so that will be a squared minus 2. Okay? Or you could have gone with the one dealing with cos squared alpha minus sine squared alpha, which again is the same thing. Right, you guys with me? Right. Then the last question, dealing with this here. The question says, sine 280, sine 280. So what do we need to do? We need to link either 50 or 40 to 280. What would it be? As a stand is none of it. Not so. So what I do is I say, okay, it would have been 270. No, it's not 270. So what I do is I first reduce it to an acute angle. Not so. So let's reduce it to acute angle. Which quadrant is this in? quadrant 4. So it's going to be sine of 360 minus, sorry, 80. So is sine positive or negative in the fourth quadrant? Negative. So it's negative sine 80. So how can I link this to one of these identities? This can be written as negative sine 2 times 40. So now this is going to be sine 2 alpha. Not so? So sine 2 alpha can be written as 2 sine alpha cos alpha. Not so? So what would this be? Negative 2 sine 40 cos 40, as alpha is now 40. So it's negative 2 into. What is sine of 40? Sine is opposite over hypotenuse. So it's 1 over a. Cos is adjacent over hypotenuse. So it's the square root of a squared minus 1 over a. And of course we need to just tidy up that a bit. Okay, so need to tidy this up a bit, which gives me negative 2 over a times the square root of a squared minus 1 over a, which is negative 2 root a squared minus 1 over a squared. Okay. Any confusion there? Other than the sum is beautiful. No? Nothing else. Okay. So we're going to do a lot of geometry. And trigonometry. Sorry, my mistake. Trigonometry. I just want to do more geometry. Because you guys must enjoy geometry the most. Right. Last question, people. It says prove that cos of 3x is equal to 4 cos cube x minus 3 cos x. Right. What do we call this? A sum. Yes. What else? And identity. Yes. So we have a left and right hand side story here. You're not going to treat it as an equation. So I'm going with the left hand side. Why? Expansion is easier than reduction. Okay. So, cos of 2x can be written as what? Oh, sorry. I'm giving you the answer. Cos 3x can be written as cos 2x, yes, plus, what is 2x plus x? 3x. So, what do we see now? Compound angle. Yes! Compound angle for cos. So what's the cos compound angle? Cos alpha plus beta. Why plus? So there is a plus. Can be written as cos alpha, cos beta, minus sine alpha, sine beta. So what's my alpha angle here? 2x. So it's going to become cos 2x, cos x, minus sine alpha 2x, sine beta x. But is that equal to that? No, man. Now what? That's not the case. So what will I keep as it standing here? Cos x. That's the only resemblance I see. Not so. So I'm trying not to change that. So what can change? Cos 2x. What else can change? Sine 2x. Now, cos 2x can be changed into any of these three. 2 cos squared alpha minus 1, cos squared alpha minus sine squared alpha, 1 minus 2 sine squared alpha. Which one of these three am I going to change it to? Sorry? The one dealing with cos. Why? Because of what you want there. He's dealing with causes only. Understand here? You understand? Right, so what are we going to write here? 2 cos squared x minus 1 times cos x minus, people, sine 2x can be written as what? Sine 2x. 2 sine alpha. It's going to be 2 sine alpha cos alpha. So sine 2x can be written as 2 sine x cos x. 2 sine x cos x. Multiplied by sine. Okay. So what I'm going to do here is I'm going to rid this from the brackets. So what is 2 cos squared x times cos x? 2 cos cube x minus cos x. What is sine x multiplied by sine x? Huh? Sine squared x. So it's negative 2 sine 2 that's just like this. 2 sine squared x times cos x. Okay. But is it what we are looking for so far? No. What do we have? We got sine cube, cos cube. We got cos. So what's the issue here? The sine squared x. People, what is sine squared x also equal to? 1 minus cos squared x. That's coming from the squared identity. Not so. Let's pull this down. Right, so what do we have? 2 cos cube x minus cos x minus 2 cos x multiplied by 1 minus cos squared x. Now what do we do? Now what do we do, people? We read the line from the bracket, not so. So what do we have? 2 cos cube x minus cos x minus negative 2 cos x times 1 is negative 2 cos x. Negative 2 cos x times negative sine squared x will give you positive 2 cos cube x. So what do we see now? Like terms. 2 cos cube x plus 2 cos cube x minus cos x minus 2 cos x. So what is 2 cos cube x plus 2 cos cube x? 4 cos cube x. What's negative cos x minus 2 cos x? Negative 3 cos x. So let's check. Is that what we were looking for? Yes. You can't believe grade 12 is so easy. Which is equal to the?
Good morning,
For homework is exercise
Claudia Fisher, can you please report?
3 on page 98.
Claudia Fisher, please report.
You're going to do for me out of number 1 the odd, number 2 the odd, number 3 the odd. The whole of number 4 and number 5 odd and 6 odd. Okay, it's a lot of work, but it's only half the exercise. Okay, so the next 2 days we will probably be looking at that exercise. People, enjoy the rest of your day. Good morning, class.